Hello, I'm Richard Lund. I'm on a journey to live a healthy 100 years. Maybe you'd like to come along. I'd like to dedicate this video to Dr. George F. Howe and Dr. Li Chin Sun, both of whom have taught me a great deal, especially about plants. This is an educational video only. If you're sick, please see a doctor. Maybe you can find one who speaks herbal medicine. Now I'd like to make my presentation. A leap forward to create a drug to treat COVID-19. My personal thoughts that gelled on Leap Day 2020. What did the Manhattan Project, Bill Gates, and traditional Chinese medicine have in common at 1 o'clock in the morning? Not much, unless you live in my brain. Let me explain. The Manhattan Project was the rapidly focused activity of the U.S. military-industrial complex to secretly develop the atomic bomb. Bill and Melinda Gates have been working to fund production of an anti-malarial molecule called artemisinin via bacteria, bypassing the plant biomass source. And traditional Chinese medicine has within its pharmacopoeia a long tradition of using natural products in people to treat diseases. Some concepts have been gelling in my mind during the first few hours of Leap Day, the 29th of February, 2020. I woke up at 1:16 with a burning idea. I got up and wrote much of what I will present now over the next few hours. These ideas revolve around the need to keep people who have become infected with the SARS CoV-2 virus from getting severe symptoms, and for those who care for them, whether at home or in hospitals, from becoming sick as well. What will turn this disease into a world disaster is the limited number of hospital beds, intensive care beds, and ventilators. One thing that I have heard declared is that we have no drug treatment of COVID-19 disease. We have medical care for serious complications, but even there the means to treat may be overwhelmed by lack of intensive care beds, by a shortfall of delivery of oxygen and of ventilators for treatment. I propose a treatment to be given at the beginning of symptoms and for immediate use by family members of infected people to reduce their susceptibility to infection. This may result in far fewer hospitalizations and especially the entry of people into intensive care. I submit that this small molecule drug may severally interfere with RNA viral replication directly, work to chemoattract the innate immune cells despite elevated hormones during stress, and work to modulate the inflammatory processes inside the host cell via downregulation of certain pathways. There is good evidence that it enters affected cells through digestive absorption and blood circulation. This molecule is currently part of herbal products sold in the United States, and in its plant biomass form has GRAS status, that's generally recognized as safe status, being sold even as an instant beverage. The twofold action of increasing immune cell activity and decreasing RNA viral replication should both make the disease signs and symptoms milder and should reduce viral shedding, thus reducing risk of infecting others. While I've had an interest in natural products and traditional Chinese medicine, or TCM, those both require plant-based material, which must be grown as crops and harvested before they can be processed for use in treatment. Even the most basic decoction is based on the availability of biomass. We have some, but we may need a lot more. And the source plants may likely have a range of biologically active molecules. Those molecules may be stronger or weaker in individual plants. So my proposal comes along with a means to test and a means to ramp up production. In the means to test, I've been reading about work done with a particular herb which has two names in TCM. One is Banlong from the Isatis indicatica root, and Chong Jie from the aerial parts of the same species. Here is Isatis indica both from the root and the aerial plant material. One biologically active molecule that has been studied from this plant is Indirubin. Pictured here are some dried plant parts. In a paper, Chong Jie et al. on Indirubin. The authors show that Indirubin regulates H1N1 susceptibility in stressed mice by regulating MAVS signaling. MAVS is the mitochondrial antiviral signal. This structure is located on the outer surface of the mitochondria. There are several pathways that it affects in these murine studies, and it also shows in vitro work to identify modes of action. The abstract summarizes, our results demonstrated that Indirubin decreased the susceptibility to influenza virus with lowered mortality and alleviated lung damage in our restraint-stressed mice model. Moreover, Indirubin promoted the expression of interferon beta and interferon-inducible transmembrane 3. In addition, Indirubin maintained the morphology and function of mitochondria following influenza A virus infection. Protecting the mitochondria is important. Further study revealed that Indirubin promoted interferon beta production through promoting mitochondrial antiviral signaling pathway. My second point is that in rapid drug production, there have been 2 recent publications for synthesis of Indirubin. One utilized tryptophan and the other glucose. Xuwang Zhang et al. Described their method of synthesis of Indirubin from tryptophan. They used recombinant Escherichia coli containing the naphthalene dioxygenase enteogenes from Comomonas species. In the other paper, Jukan also utilized a metabolically engineered E. coli. The abstract explains, methyl-alpha-aminosulfide diverins, flavin-containing monooxygenase, FMO, and E. coli tryptophanase, TNAA, were introduced into E. coli in order to complete the biosynthetic pathway from tryptophan to Indirubin. Chong et al. Presented a direct action to reduce viral load by the production of interferon beta and interferon-inducible transmembrane 3, and downregulation of IL-1 beta, IL-6, and TNF-alpha. And continuing, the production of interferon beta and interferon-inducible transmembrane 3, IFIT-M3, brings innate immune response signaling and interferes with viral replication, respectively. That is important. Supporting the role of IFITM-M3 in another paper, IFITM-M1, 2, and 3 are shown to interfere with influenza A replication, among others. See Abraham L. Brass et al. And protection of the mitochondrial membrane, where the MAVS, the mitochondrial antiviral signal, resides, and its activity with STING, stimulating interferon production gene. Indirubin has analogs that have been studied and shown to be active as well in leukemia. Indirubin has been in people for millennia in the crude form of the ingredient isatis in TCM formulas, and it was well tolerated. Indirubin may be an excellent candidate for early prophylactic administration to medical staff and to at-risk people, and at the beginning of infection to keep the symptoms manageable, reducing the need for intensive care treatment and use of ventilators. Indirubin and its analogs need to be tested with the SARS CoV-2 virus. Should it be effective, rapid development for use in humans could come, and production methods that do not depend on species-specific plant raw materials could be used. Indirubin is said to be used today in hospitals in China. Recently, Congress approved a spending package of more than $8 billion for COVID-19. While some have assured us that genetic sequencing is the answer to finding new treatments, the process to move this from bench to bedside is glacial compared to what we need to save our elder generation from early death. Natural products exist that may easily show a path to treatment while we work on CRISPR genetic manipulation and navigate the minefield of public distrust to bring us vaccine protection. While my proposed candidate molecule may strike out, there are many which have significant activity in people through herbal medicines that need discovery. I hereby advocate a Manhattan Project level of drug discovery, utilizing sources that have been tolerable to humans for centuries. Let us apply the lesson from the Pacific yew tree bark. Years ago at the American Society of Pharmacognosy meeting in Oregon, I met Mansukh Wani, one of two scientists who published the function and structure of Taxol in the early 1970s. Yet it took decades until it was tried in people. And this man is the only one I ever met in person whose research yielded a drug. Can we, the society that made a moonshot, aim at a new target with a different modality? Before we begin another conflict beyond our borders, let us address this common enemy of mankind using what we already know and rapidly use our brilliant chemists working in natural products, not to make billions for pharma investors, but to save the collective wisdom in our own people, the elders. This is my dream. For my thoughts in the wee hours of Leap Day 2020, my proposal. Thanks for listening to An Old Man Talk. Richard Eugene Lund. Submitted to my fellows via the web, 8th of March, 2020. Well, that's it in a nutshell. Well, or actually in an herb, in the root and in the plant parts, the aerial parts. I just want to thank you for listening. And I'd like to see if there's some discussion that we can develop around these ideas to see if we could do something to take things which have already been in people, make drugs out of them that have antiviral activities, which could be very valuable even with influenza, seasonal influenza, but also with the new SARS CoV-2 virus that's causing the COVID-19 disease. So, peace to you from this day in Los Angeles, California. Thank you.